Thank you very much for coming. My name is Łukasz Wcisło. I'm here to talk about correlation analysis in automated testing, as you can read. At the beginning, I want to introduce myself, tell something about who I am and how the history of my education moved me to such a spec of this presentation. Former, I thought about something slightly different, but it evolved into this. Then I will tell what was the problem and what's the purpose of this research. I will tell you about some math that stands behind all this thing. And I will go to the use cases and some conclusions, maybe some anecdote. So first of all, what was my main purpose? I was a former computational biologist, bioinformatic. I was a person who used very strong supercomputers to simulate biological processes like protein folding, in example. The most problematic issue with such research is that very prone to any performance issues. Because there are billions of billions of particles that can be connected to each other in many ways and can have influence one or two in each other. So this is the performance was crucial. And as I moved to informatics, to IT, I started to be a tester in 3MD app in Poland. I started to work with big test suites, not very big, but big enough to consider that the speed of the test, the time that it would be done and the resources consumed are important. So I thought about making it some more reasonable to do some optimization of these tests. And I think that nowadays it's a big team, machine learning, so why don't have all the tests learn one from each other? You know, if from the history, one test will know that other tests was run and almost this exact time if some other test failed. This test also failed, or if some other test was run several iterations and it couldn't reach its expected outcome, the other test would be either shortened or not done. Then I realized it was better from the beginning, because if tests are correlated in such way, the test suite is badly created. It has some wrong assumptions, and the tests conditions are badly formulated. So this is my assumption. I don't want to read it again. I want to make test suites more elegant and save some time and resources. Because for the perfect test suite should be no correlation between the tests. If there are some correlations, tests should be, I don't know, passed, because we don't need to be made. Then that may be some value measured that can even benchmark test suites, the correlation coefficient. Let's see for an example. There are tests in rows and software versions in columns. green is passed and red is failed. It seems obvious. And I considered tests Boolean functions, which are true or false. Normally, when you computate correlation coefficient, you need to do regression first, because it's Boolean function even from 0 to 1. That wouldn't make any sense. So what I took was a probability, historical probability of passing the test. That was the value that I was measuring if the test is below that probability or above that probability. Next, what I've done, it's obvious that tests that have 100% pass, it doesn't really matter for us. Just the same as software version that fails all the tests. You know, if we have a power issue at the moment of testing, it doesn't really matter. Yeah, it's not a matter of tests. So I left only the meaningful test cases, meaningful tests that have sometimes failed. And I created a covariance matrix from them. This may look suspicious, but it's really very easy math. It can be done in Google Spreadsheets. From this, I've created a covariance matrix, just as I said before, where on the diagonal is just a variance of each test that is meaningful, and the other fields are covariances between the tests. Next, I computed the Pearson correlation coefficient. It may look scary, but it isn't. Trust me. And create a correlation matrix. What we can see above, it's just a shape of the test's outcome that was from the beginning, that was our input. And below it's scattered by me. It's only half of the matrix, because to be clear, for clarification, it should have on a diagonal 1, because in each field on the diagonal, because correlation between a test and the same test is 1. Pearson correlation coefficient has always between -1 and 1. -1 is negative correlation. If something passes, the other thing fails, and 1 is positive correlation. If something fails or passes, the other test or the value is always the same. 0 means no correlation, and in a big test suite or many test suites aggregated in regression, the real values are near 0, plus or minus, but near 0. If something is like in this example, I don't consider 1, because it would be obviously error, but 0.5 or something like this, it is significant. We can do that just to validate the test suite, but it wouldn't be much, it wouldn't have much value for us. What can have value? We can, with each regression in continuous integration, continuous delivery, we can test each version and check the dynamic of changes of this coefficient. You know, if we can see that some values that shouldn't be connected seems to be correlated from some version in the past, correlation is getting bigger with each iteration, we should see a yellow light and check whether the conditions of the tests are prepared correctly. This is a real test outcome from, we're in the 3ND app, maintainers of Swiss firewalls firmware of PC engines, IPO. Maybe some of you used these routers. And this is from the test results of the firmware of one of the lines of one of the routers. We are maintaining them for above 2.5 years, but these tests are not a good example, because our test suites are evolving too. some tests were created and, I don't know, started to be used half a year ago. So we have not completed a large enough base of tests for long enough history to make this really useful. But large silicon vendors or hardware producers, I suppose it could be useful, just because there are very often cases that one person or one team is responsible for one suit in regression. All in all, they might not be aware of correlations between the regression suits. So in the conclusion, the dynamics can be useful in large sets with a large history, and this is a proof of concept. Do not consider this to be a white paper or something like this. Idea is quite new, and we started to work on this more seriously on our firmware, with our firmware. This is an anecdote, Anscombe squatted. Maybe some of you know it, have heard of it, because these 4 sets of data have the same, as is written below, mean of x and y, variance of x and y correlation, and so on, although they are obviously different. So we have to be very, we have to look. I don't consider the statistics to be a red light, to be a fail, if something rapidly changes and something is rapidly grow, because it may be from some other reason. But yellow light should be considered visible if something occurred like this. This is bibliography, and thank you for your attention.
Have you heard of this approach? It sounds very friendly to what you're doing, and there you can get this result of redundant tests almost immediately. So you don't even have to calculate any statistics. You just find the tests which are most effectively killing all of the possible mutations.
I don't do any computations. All the computations are done in Google spreadsheets. Thank you. Yes, I heard about it, but this is a new concept. We are just looking for ways that could improve our test suits, and I think it should be considered. Thank you.
What was the name of the method? The method is called mutation testing. So it's been a number of talks here in this room actually for the past years. Tools like Python, the C++ tools for this approach. Check it out. It's really a big branch of testing, and it's emerging.
Beg your pardon?
Yeah, because
I can hear you.
people who are watching the stream have not heard that, so you should probably mention that there is a thing called mutation testing.
Yes. Have I heard about the mutation testing? Because it can be used, it can simplify all the computations that we used here with statistics. Yes, we've heard about it, but it's in progress. We are looking for new ways to do it, and I think it be considered. Thank you.
Any other questions? Yeah? No?
Thank you very much for your attention.